using sine a plus b, prove that sine 2x is identical to 2 sine x cos x. Okay, now the proof. Now while proving this, an identity has to be broken down by the logic of usually started from Euclid, how he proved theorems. Is take the left hand side, let me write LHS, left hand side, and start breaking it. So sine 2x can be thought of as x plus x and the clue is given here, sine a plus b, so x plus x. So the first one is a and the second one is b. So we have from this rule sine cos cosine. I can write sine x cos x plus cos x sine x, and we know sine x cos x or cos x sine x, the same thing, just rearranged together. So if we add it up together, it will be 2 sine x cos x. Therefore the left hand side is now equal to the right hand side, or we can say the identity, and we can write a little QED here, which means proved. So it's Latin, perhaps it means quod erat demonstratum, that Euclid used to write. After a proof he would write QED, quod erat demonstrantum, something like that. Now the next one is proving cos 2x. So the question would be, using cos a plus b and sine a plus b, prove that cos 2x is identical to cos square x minus sine square x. But usually this can also be like this. It can be this, or it could be prove that cos 2x is identical to 1 minus 2 sine squared x, or it could be something like this, prove that cos 2x is identical to 2 cos square x minus 1. Doesn't really matter. If you can prove this, other two can be done by the basic trigonometric identities. Okay, so this is the first one and this is the second one. Okay, let's scroll down here. Okay, now when we are talking about the first one, so here cos 2x, so we can take left hand side. So cos 2x can be written as x plus x, and it is using the cos a plus b identity that we have seen, which is cos cos minus sine sine. So we can write cos x cos a into cos x, which is cos b. So here's the plus here, we have to write minus here. So sine x into sine b, so which is quite simply cos square x minus sine square x. So therefore left hand side equal to right hand side. Now in doing number 2, cos square x is identical to 1 minus sine square x, which is, these two are more common. The first one is not that common, these two are more common. In order to do that, so what we do the whole thing, we write left hand side, start from the beginning, cos 2x is x plus x, so we write cos x minus sine x, and we write cos square x minus sine square x, and you'll remember about the basic identity, which says sine square of an angle plus cos square of an angle is identical to 1. Look, I'm not writing the 3 line all the time. That's fine, that's completely fine, but the 3 line means identity. So from here we know that cos square can be expressed as, if you send the sine square to the other side, 1 minus sine squared x, and similarly sine squared can be expressed as 1 minus cos squared x. Now what we want to do here is we want to express our answer as 1 minus sine squared x. So we have to get rid of this cos squared x, and we can use that identity as 1 minus sine squared x, and we have minus sine squared x. Now if you remove the bracket, it will be 1 minus sine squared x minus sine squared x, it will be 1 minus 2 sine squared x. So therefore the left hand side is now equal to the right hand side, and we have proved QED. Proved. Sine x multiplied by sine x is denoted as sine squared x. It has nothing to do with the angle. Sine ratio of the angle x, this should be the complete term. So whenever sine x is multiplied with sine x, some people might mistake it as sine x squared. No, the angle cannot be changed because the angle is the same. So this is wrong. It is not the angle that is being multiplied. Even sine cubed means sine x multiplied by sine x multiplied by sine x. It is completely different to sine x cubed, which means sine ratio of the angle, which is x cubed. So this is important to remember how the square of a sine is expressed. So we will start with left hand side, so which is cos 2 theta means cos theta plus theta, and this is, we know the identity, it is cos cos minus sine sine. So we will write cos theta minus sine theta sine theta, and again we can write from here cos squared theta. Again, this is not cos theta squared, it is cos squared theta minus sine squared theta. Of course we have to express this in terms of cos squared theta, so we have to find an identity of sine squared theta. We can write cos squared theta minus, we have to give a bracket, that is very important, minus 1 minus cos squared theta. So we get cos squared theta minus 1, minus into minus is plus, cos squared theta. So this would be 2 cos squared theta minus 1.